Hi, welcome back to today's lesson in Principles of Engineering with myself, Mr. Yates, at Patterson High School in Baltimore, Maryland. Today we're going to look at a truss like this one here, and how a force like this 100 Newton force that you can see right there affects the rest of the truss structure. We study trusses when we are learning about building towers and bridges in the statics unit of our Principles of Engineering course. To start out with, I've drawn the very same truss you just saw, which came from our recent quiz, much larger. Do take note of a few important points about this truss. Notice that the only external force that we see in this whole picture is the 100 Newton downward arrow force right here at the joint of the structure that I've labeled B. Notice that I have gone through and labeled A, B, C, and D, the four joints that make up this structure. Notice that there are two supports or two connections. One over here is a pin connection that we saw from the original picture, and one over here is a roller connection that we saw from the original picture. I've also labeled some distances on here. We know from the original quiz question that this length is 3 meters along the bottom, which is the same as the length 3 meters here along the top, which is the same as the height. And height, remember, is always measured straight up and down, never along the diagonal. That diagonal length is not 3 meters. But this height here is also 3 meters. Those will come in handy later on, as will this angle here, which is 45 degrees. This angle is 45 degrees. This angle, as you can see, is a right angle, 90 degrees. Another right 90 degree, 45 and 45. I've only labeled one of them, but it will be important later on to know that we have 45, 45, 90 right triangles. Okay, the very first step that I do is actually just redraw the entire diagram all over again, only replacing the two supports, the pin connection here and the roller connection here, with forces. Now these forces don't have any directionality, any arrowheads on them yet. We'll get to those later on once we figure out what direction they do need to be pointing. But for now, we should remember that the pin connection that was right here at C, this pin connection right here, is always replaced by two forces. And the roller connection, like the one here at D, is always replaced by one force. So you can see here at C, the pin connection got replaced by two perpendicular forces, and at D, the roller connection with one force. Now, always think about this like this structure is sitting on the ground, or in some cases it could be like hanging off a wall. But in whichever case, one of your forces is always going to be pointing down into that ground. Or if your connections are both on the side here, then they would be pointing into the wall that the truss structure is hanging from. So that is a way to avoid any careless mistakes, like drawing this second connection straight up right here. No, it's not going to be going up because there's no ground or wall supporting it above the point C there. Okay? Otherwise, this is the exact same picture as the previous one. Just the two supports, the two connections replaced by forces, and I've taken out some of the extra information like the 3 meters, the 45 degrees. We might come back to them later, but for now we don't need them. My next step is I will draw 4 free body diagrams, one for each joint. One for joint A, one for joint B, one for joint C, and one for joint D. Now, even though a free body diagram can be entirely separate from everything else, remember, a free body diagram is only one object, in this case the joint of the truss structure, one of these only, plus the forces that act on that object, which we're going to draw in a moment. So really I could have A on this page, B on another page, C on a third page, and D on an entirely different fourth page. But it helps me see some of the connections because A and D are connected by a beam. Back in the original truss structure, A and D are connected by this beam. Because of that, they're actually going to have the same magnitude force coming out between both of them. And the arrows will be pointing in opposite directions because that beam is either in tension or in compression. So it helps me to draw my 4 free body diagrams on the same page, and if possible, I want to draw them as close as possible to where they are in the actual truss. Know that A is straight above D. A is directly above D. A is still directly above B. B is off here to the side of A, and C is off to the other side of D. Just like on the original, B was off here to this side of A, C was off to this side of D. Keeping them in the same general location that they were in the original truss will be helpful in seeing which parts match up to which other parts. We'll take a short intermission at this point. Please stay tuned for part 2 of truss calculations.